Okay, Algebra 2 students, so today, briefly in a video lesson, I'm going to teach you how to vertically shift sine and cosine functions, which is going to mean to move them up and down. But before we go there, let's just take a look at a couple of warm-up problems. We've already studied how to determine the amplitude and period of sine and cosine functions. So for example, when I have the function y equals 3 times the sine of 2x, I know that that 3 is the amplitude, which means that the high points of the sine wave will be at 3 and the low points will be at negative 3. The period of a sine or cosine function is 2 pi divided by b, so 2 pi gets divided by 2. The 2's cancel out, and we say the period is pi. And what that means is that the wave is going to start at 0 on the x-axis and go to pi on the x-axis. So notice my first point is at 0 and my last point is at pi. And then to label the other 3 tick marks between the beginning and the end, you take the period, whatever it is, divided by 4. So pi divided by 4 is pi over 4. So the first tick mark is 1 pi over 4. The next one is 2 pi over 4. The next one is 3 pi over 4. Oh, and look, it's nice. The last one is 4 pi over 4, which is pi. So then I drew my sine wave, middle, high, middle, low, middle. Another example, y equals negative 4 times the cosine of pi times x. The amplitude is 4, and the period is 2 pi divided by b. So 2 pi divided by pi, the pi's cancel out and the period is 2. So that means the wave is going to begin at 0 and end at the number 2. So my first tick mark is 0 and my fifth tick mark is 2. I take my period divided by 4 to get 0.5. So 0, 0.5, 1, 1.5, and 2. And then, because my amplitude is negative, my cosine wave is going to reflect and do the opposite of what it normally does. So it's going to go low, middle, high, middle, low. So hopefully you're comfortable graphing sine and cosine waves with different amplitude and period. All right, so now moving forward, in this lesson, we're going to show you that we can translate sine and cosine functions vertically. We refer to this as vertical shift. So for example, what you're seeing on the screen already is that I've graphed the parent function y equals the cosine of x in black. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. I've plotted those 5 points here and here and there and there and there. That's my cosine wave. Now, to graph y equals the cosine of x plus 2, that plus 2 just says take all of these y values and add 2 to get your new y values. So I would have a 3, a 2, a 1, and then a 2, and then a 3. So if I plot 0, 3, and then pi over 2, comma 2, and then pi, comma 1, and 3 pi over 2, comma 2, and 2 pi, comma 3. If I connect those 5 dots, we see that the black parent function vertically shifted up 2 units. What I normally encourage my students to do is to draw the midline dotted and label it. So what you're going to do is you're going to soon realize that the plus 2 becomes the new midline. Instead of fluctuating above and below the x-axis, this function is fluctuating above and below the midline 2. Notice that the amplitude is still 1 because the distance between 3 and 2 is 1. And the distance between 2 and 1 is 1. The amplitude is still 1. All right, let's take a look at another example. Y equals the sine of x, the parent function, is graphed. And then y equals the sine of x minus 3. Take these y coordinates and subtract 3 from them, and you'd get -3, -2, -3, -4, -3. So 0, -3, pi over 2, -2, pi, -3. Did I mess up there? No. Pi, -3. And then 3 pi over 2, -4. And then 2 pi, -3. So notice, connect those dots, it looks like the sine wave, sorry about that, has translated down 3 units. Well, what that means, sorry about that, is that the midline is y equals -3. So you see, if I draw that in, you can see that y equals -3 is the line that the function is fluctuating above and below. So that's all there is to it. If you add or subtract a constant onto the end of a sine or a cosine wave, you will make the midline vertically shift to that new location. That simple. So let's get some examples in our notes. I think 2 will do. So consider that y equals 4 times the sine of 6x plus 3. So we know that the amplitude is 4. We know that the period is 2 pi divided by b. So we know that the period is pi over 3. Okay? The vertical shift is up 3. That's what that plus 3 means we just learned, right? So here's what I recommend you do. This works very well if you follow this. The first thing I teach my students to do is graph the vertical shift. So when we say that the vertical shift is up 3, we mean that the midline is the horizontal line y equals 3. So what if I come up here and I pencil in y equals 3? Okay. Secondly, the amplitude is 4. That means the high points will be 4 above 3, and the low points will be 4 below 3. Well, if I go 4 points above, I seem to be at 7. And if I go 4 values below, I seem to be at -1. So the highs will be at 7 and the lows will be at -1. Now, lastly, the period is 0 to pi over 3. So 0, tick mark, tick mark, tick mark, and the fourth tick mark will be pi over 3. Wouldn't this be pi over 12, 2 pi over 12, 3 pi over 12, and so on? Now, what does a sine wave do? It starts at the midline at the first tick mark. It goes high at the second tick mark, midline at the third, low at the fourth, and midline at the fifth. And so you have an accurately graphed one period of this function. It's all about labeling the axes. Okay. Y equals -3 cosine pi over 2x minus 5. The amplitude is 3. The period is 2 pi divided by pi over 2, which would be 4 when all is said and done. And the vertical shift is down 5, which means y equals -5 is the midline. So if I pencil in y equals -5 first. Secondly, the amplitude is 3. So if I go 1, 2, 3 tick marks above -5, I'd be at -2. And if I go 1, 2, 3 tick marks below, I'd be at -8. So that shows me that I know the amplitude is 3. Now, lastly, the period is 4. So we're going to go from 0 to 4. Seems to me like that's going to be 1, 2, 3 as the labels of the other 3 tick marks. Now, what does a negative cosine wave do? It goes low first, middle second, high third, back to the middle at the 4th tick mark, and back to low at the final tick mark. Connect your dots, and you've graphed one period. Could I go 5, 6, 7, 8 and graph another one? Of course I could. Back to the middle, back to the high, back to the middle, back to the low. And I could just keep going as much as I needed to. So hopefully this lesson was as simple as I intended it to be. Now you can complete your worksheet.